on the first part of the stack. Then the inside there are, so we have there are the local variable integer value integer I. So this local variable starts from the stack area. Okay. Then, for example, if you allocate the array or temporary space, so in this case the values is the m along. So what is the m along? So eventually in the process we are going to use the memory space to keep the variable. How can you keep the variable? First, one way is you can define the variable like the integer x, integer y, and something like that. Then based on that the data type, the program know for example integer x, it needs the 4 byte of space. Then allocate the 4 byte of space in the memory. But sometimes you don't specify the name of the. Sometimes you want define your own data structure. At that time, you can use the allocation, the function, the malloc. There is another type of memory allocation, the function, the calloc or the ralloc. They are much similar, but mostly you may use the malloc or the calloc. So in case of malloc, if you are using malloc like 100 bytes will be allocated. But you are not going to initialize. On the other hand, the calloc, if you are using the calloc actually filled with the CO, default value. So you can use either of them, but mostly it depends. Some of them like the malloc, so the others like the calloc. But calloc has the 2 parameter value. You should be careful. But anyway, so in this case, we are using malloc. Size of the integer multiplied by 5. So integer need mostly the 4 byte. So times 5, so 20 byte. So 20 byte space will be allocated here? No. So the heap has only pointer, the location of that. In this case, the value. The values will be created 20 bytes somewhere your memory, where it's free. Okay? So, in this case, when you use the value using the malloc, so it will be created the heap area. But heap does not have this one is the 4 byte times the 5, so 20 byte. No. Instead, it has only values. What is that? This is a pointer. And somewhere in your memory where the 20 byte is available is a point, the address of this one. Then once this value is done, this area will be free. You don't have to free this one. Just free the pointer. Okay? Then you can save time to manage the data. Also this one is angle, lost the pointer, which means it can be free later. Using what? Using garbage collector. Garbage collector, no. Which one is used, which one is not used. So you can maximize the utilization of the memory. Then, this is the same thing. So still we are using the value. Here, for example, values I. So you know the values. Values is here. That has the address of value. And the I in case of 0. So first, the array will be the read. And so. Then if this one is done, the main, all this one is free, and the main will be free, then the process will be terminated. So this is the process, the structure. So this is more details of the memory structure used in the C. Okay. So it's based on the x86, the processor. So you can see, but the basic architecture is the same thing. You can see left-hand side. So it's a text area, and the data area, and the shared variable, shared area, which means it's the heap. And the top part is the ARGV, ARGC, is for the argument, and the going down is the full stack area. So most of the process has the very high level, it's the same thing, but details, they have the different. Like the, someone allowed only the, as a default, the total memory size is 32K. They are not such a big. So even though you learn the Microsoft Word, when you check the size of a processor, it's 100 megabytes, 200 megabytes. But their initial size of the processor is 32K or 64K, like that. Okay? When they count the size of the entire memory is they're gonna count all the temporary space also. But their process structure is quite small for efficiency purpose. So they have the text area, data area, shared area, and the stack area. So these four are the main part. But more details, so it's all different. Because of that, if you have the exactly same source code and the same thing, but except the only difference is the CPU. I'm using AMD, not Intel. You need to compile away because of that reason.
So, Professor,
yes.
given the text area and everything is included in the 32 or 64 kilobytes?
It depends on the CPU. So they have the detailed specification. Then compile should know. Compiler, when you call the compiler program,
Yeah.
okay, compiler should know the detailed layout. In other words, data structure. Then follow the exact guideline, kind of, to design your process. Okay. So at that time, somebody may use some of the processor use the 10K for the text, but the other may use the 20K. It's not such a big. We will see how to manage such an area later during the memory management. We don't have to bring the entire program into the text area. It's a waste of space. Instead, we will switch in and out by page. So that's a good question. We will learn. That is the 90% or almost 100% the important concept of the memory management. As I keep saying, if we have unlimited resource, like the unlimited memory, we don't have to learn this one, right? Just allocate. You can use whatever you want. But unfortunately, we have very limited resources considering our data, right? So because of that, we need to think of a very efficient way to use the limited memory space for many programs. Yeah. So we understand that if you double-click the program or if you type the command, then your process is started. It's the burst of process. It's the start. So your process. So when you double-click, let me change. So double-click or the command and enter. So your process is started. At the time, it's called the new process. So process has a kind of status, like when you are born. So you are a newborn baby, okay? Then growing up, toddler, then the kindergarten and elementary, the school student, and middle school, then high school, college, and the job, and adult, and old, and then pass away, right? So we have the life cycle in our life. Similarly, process has the life cycle. So it's starting with the new status. Then once new, but the new does not mean it can be executed. So you should be ready to enter the elementary school. You need to know how to read the ABC, how to calculate the plus, minus. You should be ready. So once you're ready, this is called the running process. So running the status. So at that time is the kind of the ready to be executed by the processor. Okay. Sometime ready. So ready status. Okay, not running. Then once you are ready, then if the CPU select this process, it will be the running the process. If everything is done, this will be terminated. So this is a life cycle of the process. So first start your program is new. Then if ready to be executed by the CPU, it's a ready status. Then once selected by the CPU, then your instruction is executed, is running. Then everything is done, then the terminated. However, sometimes when you run the process, for example, so when I write the paper, so I'm the researching, then running. But I need the reference, so I ask my assistant, why don't you go to the library, bring the paper 2000, published by the Professor Lee. Okay, so you can ask the assistant to bring a paper from library. Then at that time, if I ask to bring a paper from library, can I do anything? I cannot do anything because without the reference paper, I cannot proceed. So I need to stop my job until my assistant get back the paper. So at that time, it's called the wait status. Then once the assistant bring a paper, I can restart my job, right? Because the paper is ready. At that time, it's not going back to the running. Instead, it's going back to the ready. And waiting for what? CPU. The problem is how many processes in ready? Many processes, P0, P1, P2, sometimes 100 processes are in the ready. This one will be managed by queue. What is the queue?
Data structure that does first in, first out.
First in, first out. So it's a first in, first out. So P0 come in, then next process for the CPU is a P0, then P1, P, something like that. This is the first in, first out. However, not always. There are a bunch of other algorithms. So this algorithm is called the CPU scheduling. So CPU scheduling is very important. Do you think it's fair, first in, first out?
Well, it depends on some
It depends, right.
first, and then they're not really like that.
It's fair in the word map register. However, in computer, I'm in a hurry. I need to move to next. But if other process is in first queue, I cannot move next slide. Moving next slide is more important. So there are a bunch of different ways to select the process for the running. Why? Because how many running process on your computer?
Usually
One.
process.
If you have the multi-core, one multi-CPU, it can be one or a little bit more. Less number. How many ready? Bunch of. So we need to select the one processor for running. Then, another important thing is, so during the wait status, the CPU cannot do anything. during the wait process. So I cannot write my paper until my assistant get back the data. So what am I supposed to do? Just to wait? It's a waste of CPU, waste of my time, right? I can do other things. If there is a wait status, so I can switch my job to the advisor. So my job it was a writer, but it's a wait, then I switch my job to the advisor. So select another process for the running. Okay, so this is the wait and this is the running. So if the data is coming, go back to. In computer program, as I said, all computer architecture we can understand as well. Input and output. Most of code that we have seen, you need to read the data from memory to register. However, not all the data are in memory. So from time to time we need to ask, CPU ask, if there is a read system library. What happened? We learn. Interrupt. Okay? Interrupt. Stop. Then ask, read the data to what? Disk controller. So disk controller received the request. Then by following the instruction, embedded instruction inside the disk controller. In other words, disk driver. Driver program know how to read the data. Once read the data, ready. Then, meanwhile, this process is in the here, wait status, wait queue. Then, once the disk drive read the data from hard disk drive and interrupt, I'm ready. I'm ready for the data you request. Then, this data will be loaded into the memory. Send the data to the memory. Then CPU, operating system, no, this data is ready, right? Then this process go back to the ready queue. Then once this process is selected, then CPU can read the data from the memory. So there are 5 status of the memory. So this status is very important for what? To manage number of processes. As we learned before, current operating system is not only for single process. Many programs are running together. So multi-programming. So in one memory we have the OS, process 1, process 2, process 3. But CPU is only one. They need to share, even operating system has a process. They need to share the CPU. How? By considering the life cycle, status, process status. So there is a process state, who manages this and how do you manage this? Any idea?
To manage which part?
Manage the status. How can you manage the process status for each process?
Wouldn't they have another structure that sort of describes?
Another structure, very good idea. What kind of structure? There are 2 options. We can create a big table. That table has all the status of this one. Or we can create the table for each process. Whenever process is created, or whenever the newborn baby, whenever we have a newborn baby, we create the birth card like that. Okay? Then we manage it. What is the name, social security number, and mom and dad. Okay? The birthday. Like that. So, in other words, in case of process, PID. Okay? Process ID. And the process state. Process state. And program counter. And all information about the process. we can create, instead of creating one big table, it's overhead, because all process need to access one centralized table, right? It's a conflict. It's a race condition. So instead, why don't we create one data structure for each process? This is called the process control block. It's called the PCB. So PCB will be created for each process. Whenever new process is created, we create the PCB. So where is the PCB? Memory. Whenever this process is created, PCB is created. Then, instead of checking each and every process by the operating system, what we're going to do is just student card. I don't have to ask each and every student where do you live and what is your birthday, what is your major. So do I need to check each and every student? It doesn't make sense. Instead, I can check only student card. It's kind of a student card, okay, on the memory. So PCB will be created and the operating system manages the PCB for each process. In other words, Q. I said the ready Q. What is the item of the ready Q? Is it a real process? No, we don't have to. Instead, Q of what? PCB. So I have the Q of the student card. Instead of line up all 1,000 students line up as a queue, then check. No, they are not going to come to my office. Instead, the student card is an efficient way. So we are going to manage the only PCB. When we create such a queue, so PCB for process 0, PCB, PCB, PCB. Then select the next process, and so on. So this is the process state and the piece process count. Okay, so this slide shows the exactly same thing that I mentioned. Depending on the operating system, some little bit difference, but the basic one is the same thing. So you can see when you start a new process, it's a new state. Once it's ready, okay, admission and everything, so you are ready, and the PCB will be added to the ready queue. It's managed by the queue structure. Then, OS is called the dispatcher and or scheduler. Scheduler, that is a real. Scheduling is very important. So there exists the scheduler process, system process. That process is only in charge of the selection of the process. That's very important, right? Because the process will get the CPU resource. In other words, executed. So that is a ready queue. Then we can schedule. We can select the process for running. Then, if everything is done, terminate, exit. Otherwise, if there are I/O, it's called I/O wait. It's called moving to the wait. Do I need to really move this process here? No, we don't have to. Instead, only PCB will be just to check this process status is waiting. Then, if the return code is coming from the disk controller or I/O device, moving back to the ready, and I'm ready to get the CPU resource like that. So this is a scheduler will work for this part. And so this is a scheduler, I/O wait, and go back to the ready and exit. Okay, so how can we manage this one? Using process control block. So what kind of information inside the process control block? All of this, everything regarding to process. Like the student card has all the information about the student. So first, process state, program counter. I explain what is a program counter. It's the address, location, or address of the next instruction. Because as we have seen here, process will not be the process from to end, beginning to end. Instead, sometimes stop and going, stop, going. So we need to know, CPU should know where is the next instruction to be processed. From time to time, I'm asking, where am I to? So I forgot the point that I explained, but which means we need to remind what is the next topic, what is the next instruction to be executed. Also, another important information managed by the PCB is CPU register. What is a register?
It's in the form of memory.
Memory. It's a storage in CPU. You learned the microprocessor class.
Yeah.
Register is the register A, register B. A plus B, store the B. It's a storage. It's a small storage. But what if? So you process 0. What happened on the memory? At the CPU. So CPU has the current instruction over here and register A, B, C, D. So 0, 1, 1, 0, like this way. What is processor 1 is the next process. You need to delete all the information because this current CPU is for the P0, right? You switch. So for example, I'm advising a student, but it's a 5 minute maximum. So we need to continue. But then I have the student file here, and you're the final exam and midterm exam. So when I switch to the next student, do I need this information? No, it's the student A. I need the student B. So throw away all of this. Maybe next time I'm going to continue advising. So take the photo, snapshot. And next time I can remind, where am I? So to do that, all this information stored at the PC. Next time, process 0 is coming again. Then this one go back to here based on the snapshot. So copy all the information. Then continue, resume the processing. So because of that, CPU register, CPU scheduling, memory information, accounting information, all information are PCB. So if you are familiar with the operating system, so there are many useful. For example, let me so this is my operating system, macOS. If you type the certain command, it's called pop. It shows the very details of your operating system process. June is the top priority, 70% of the CPU. For example, the Win server is 30%. The other Google Chrome, they cannot get the CPU information. And how many processes? 447. And among them, only 3 are active, running. And the other 443 are the sleeping. And the average load is the 5 processes at the time, and so on. How does the operating system get this information? How? From the PCB. You can read the process file. Yes.
So it's the same as like Task Manager?
Yes. Very nice. So Windows is a task manager. Where does operating system get such information? Read all the information about the PCB. Read all information. That's sum up, average, and so on. Nice display. Okay? Because PCB has all the information that you want that operating system need. Okay?
Professor, what is different between sleeping and UDD? 3 running and 400
We
something.
will see. So there are different status of the process. Active, or sometimes the idle, sometimes the zombie, sometimes the open, sometimes the demon. There are many, many different types of the status. We will see one by one later. Okay. So basically, running means it's selected by the CPU. This is a dual core. So because of that, mostly 2 or 3 running. Okay. 2 or 3 running. But the other sleeping means it's in the ready queue. This is a running queue. This is a ready queue. Okay. That's the difference. There are the different.
That means the sleeping not sharing in the CPU. The sleeping,
Yeah,
no, not
they
sharing.
are ready.
Ready. Oh.
So, and also, empty state is not preempt state. Later, so this comment is not available here, but OS will be. Okay, go back to here. So, this is the process control group. So, for example, Linux has a very detailed data structure for the PCB. So, this is the example of that. Okay. If you want to see all of this, you can go to the Linux provide all the source and the header information, data structure information. So you can go to any Linux operating system, go to the include and Linux, so you can find the header information like that. Header information means data structure. We will discuss more about the thread. Just before, if you have a good eye, there's a number of threads over here, right? Do you remember? So running, sleeping, and thread. So what is a thread? So we will see more about the thread in the next chapter. Okay. Then, as you realize, it looks like the scheduling is very important, right? For example, I had 10 students outside waiting for me. If I had you, so I give most of my time for you. Then the other students are waiting outside, 2 hours, 3 hours. It will be disaster. They will complain and report to the student like that. So same thing will be happen in computer system. So because we have a number of processes but limited CPU resource. Mostly 1 or 2, 3, 4. So running, as you can see, the running process is only few number of. So which means we need to select. But how to select is the important. That is the CPU scheduling algorithm. As Tanya mentioned, first in, first out, as a queue. Looks like the fair, but in computer it's not fair. Because right now, my most important job is the PowerPoint. But CPU takes all the taken by what? Zoom. Because of that, the control of the PowerPoint is slow, looks like. The Zoom takes that doesn't mean the Zoom takes the 7 minutes, then the other 3 minutes, not like that. It's a millisecond level is switch, but the Zoom is taken by the CPU more because it has a priority, like that. Okay, so just first in, first out is not fair. So we need to consider the many different algorithms. We will discuss more details how to select, which is called the CPU scheduling algorithm. Okay. Also, how can operating system manage a number of processes using PCB? So this is the queue. Okay, queue has, as you know, do you remember the linked list in your data structure? Linked list. So this one is the first data structure you learn in your data structure class. So, linked list. But this one is based on queue, which means first in, first out. So this one will, if there is an in over here, you can add point like that. But which one was the first one? This one. So this one will be selected. First in, first out. So Based on the linked list, we can implement the queue data structure. So it's made by the queue. In real implementation, how does it happen? It has just a pointer. Pointer of this one. Pointer of this one. Pointer of what? Address. All of them are in where? Memory. It's in the memory. So you can use your experience on data structure class when you implement your operating system. Okay. I really like the operating system because operating system itself is a pack of data structure. So everything is data structure. Process is a data structure. I/O, the management is a data structure. Memory is a data structure, and algorithm. So as you can see. So this is the ready and wait queue for the process management. So we will see more details of the scheduling later. Then I mentioned the CPU should change the process, right? Then when you change the process, you need to copy everything. Like when I have the number of students outside, the 5 minutes, the student A, next student B, next student C. This change is called the context switch. So context switch means, so when something happens, I will explain what is a something. Something happens, CPU should change the process, next selected process. At the time, what happened? So what happened here? So this is a current process 0. Then something happened. I will explain what is something. So something happened, I need the CPU should change it from process 0 to process 1. At that time, you need to save all current status snapshot of student A, process 0, and save to the PCB. And read the data from PCB 1. Read the next student information snapshot and bring on my table. That is this. During that time, stop here. Stop here. However, this time, can I do any advising while the switch the student? No. So this is the waste of CPU time. So because of that, if more and more context switch, is it good or not? In terms of performance, more context switch means less performance because of this. So for example, think about extreme case. I'm going to switch a student to be fair, just 30 seconds. So line up. So 30 seconds I advise and change. 30 seconds, 30 seconds, 30 seconds. Probably I cannot do anything. It's because of such a transition time. However, if you have the less context switch, is it good? Not always. Think about, I have a student lineup. I will give the 10-hour advising. 10 hours for each student, because I don't want to switch every time. What happened to the other student? Will be killed. Right? So it's a complaint. It's not fair. So you need to find the proper, optimized context switch. But it's the millisecond level in computer system. Not like the advising. In the millisecond level, context switch happens. Okay? So this is a context switch. So context switch is really important matter in terms of the performance on your system. So this is a context switch. Because during the context switch, the most important part is read and write. You need to read the data from memory, PCB, bring to the CPU, and write back the CPU register to the memory. So a lot I/O will be happening. What about the mobile system? Mobile operating system like the Android and the iOS? Can they do the same thing?
Yes.
Yes, they can do the same thing. But first, early generation of the mobile operating system. As I said, most critical part of the mobile operating system is what? Energy, battery power.
Yes.
So if you have all the process in the ready queue and running, so it's a consume what? The battery.
Yes.
So it will die soon. So early generation of a mobile operating system allow only one active process. The others you should not come to my office, just at your home. Then when I call, you can come, because I do not have enough space outside.
This for the early models.
Early model.
Oh, okay.
But people complain, students complain, right? So they allow more and more the foreground,
Yes.
the active process, but they cannot be displayed, because display part is most power consumption. So only one. But nowadays you can picture in picture, but that actually consumes a lot of battery.
Yes.
So you will complain, right? So your battery will be died within second. While you are watching the YouTube, you can browse and stuff like that. Because so it actually has the multiple, the foreground, the active processes, and consume memory, as well as the display.
Yeah, I see this is the new model for the Samsung. The Samsung Note can connect as to the monitor and work as a computer.
So as you know, in terms of technology, it's not difficult. The problem is whether we can save the battery power or not. So mobile operating system focusing on not maximize the CPU, not the higher utilization, instead how to save the energy, the battery power. That is the critical part when you design the CPU scheduling and so on. So but technology is not very difficult to picture in picture or run all the foreground. Then finally, so I understand how does it work in the operating system. The processes are started and run and wait and selected and so on. Well, question is, how does operating system create the process? So we will see that is the most important part of the operating system, how to create the process. So 5 more minutes. So the next 15 minutes we will have the exercise. Okay, let me change. It should work. Yes. Much better. First, this is your entire memory. Lower address 002, higher address FFF. So I'm not going to illustrate all details of the memory structure, but you probably should have what? OS. Right? So OS, when you illustrate the OS on the memory, what does that mean?
It's always running.
Just OS? It's a process. All data structure on memory is process. So, what kind of process will be reside on the OS part, the lower address part on the memory? What kind of process? Do you remember the kernel? Kernel is the program, operating system program, most core part. So you need to rebuild the core kernel, you need to develop the kernel. The VM Linux is the name of kernel in Linux. Windows is the name of the Windows kernel. So kernel will start the first program. Sometimes it's called the init process. Some of them use the schedule. Even schedule is the process name. So let's say that init is the most popular. It's the first process. So process is managed by the name? No. Computer don't understand the name. Instead, always number. So it's called the process ID. So PID. So PID is the recognizer. File. So please search your file. Search by what? Name? No. Computer use file ID. Actually, file descriptor, FD. So all this one is not important. Name is so process ID. So process ID. So let's say this is a 0. Okay, process ID 0. Then, as I mentioned many times the last 2 weeks, process will be created by what? Parent process. So this process is kind of the Adams and Eve. First, parent. Okay? Then create the child process. Only parent can create the child process, no other. So this child process will be assigned as process ID 1. And it may have the sibling. Mostly, this is the first generation of the processor, system process. Somebody consider this one is a part of the operating system. Because when you start up, it's automatically started. Right? So, this one is for swap. This one is for network. This one is for the internet. Like that. So you will create a number of system processes and so on. This one create another process, another. And 100 and 200 finally. This one is shared program. That you start the terminal. When I start the terminal, that is this shared process. For example, if I here. So when I type the PS, the last one is 77940 is the G shell. This is the last one. If you go back trace the parent of that, it will be init process. So for example, if I type PS minus EF 774, you can see this is my current process, and parent process is here, and not this. Parent process is here. 779.37 is the parent process. So if I, right, 779.37, you can see this one, 808 is a login process, is the parent. So login process is the 7797. So this is the 77937. So my share is 77940. Then this login process is created by 808. So 808 is here. What is the parent process? 1. So this one is created by number 1 process. So that is the terminal. So terminal is 1. Okay, like that. So always the process is the tree structure. Then problem is how to create. How to create the process.
Don't you like copies? And then
Copies. So think about are you brand new from the parent? Mostly inherit. It's the DNA, the mother side the DNA, father side DNA, and the combined. Then your DNA, right? But the human being has what? Mutation. That's the reason you are different from your parents a little bit. And sometimes better, sometimes worse. But it's the DNA and mutation. Exactly same? Not exactly, but that's very similar idea. So we can create the child process like this one is the P0, parent process. Then when P0 create the process, first time, copy. exactly copy. Actually, at that time, even not allocate the memory. Process table. There is a process table, P0. Then P1 is admitted. However, in physically, it's a station. Station. Depending on the command. So this process is done by fork. So fork system library. System library create the process and assign the process ID. But it's exactly same as what? Parent. First time, just copy parent. Nothing different. The only difference is it has the process social security number only. Okay? Then, but I want PS command for the child process. Then, next step is program instruction will be loaded. At that time, we cannot share the same program, right? Instead, at that time, copy P1, then write the ls command, the program. Then this is the child process. So this one will be done using exec. So two system library will be used. One is fork, another one is exec. You heard about the difference. There is a flip fork. So fork actually copy, but this part is shared with the program, this part. Only the heap and stack and global data area will be allocated. However, flip fork even does not create share or share, but during the exec, you will create allocate the memory for child process for efficiency purpose. Okay. So once again, when you create the process, there are two steps. One is copy parent. Nothing different, but the only difference is the process ID. So assign the social security number. Then if it's ready, then give the exec. Exec means it's its own code. Like if you type ls code will be loaded into the memory. Then at that time, parent is wait. Wait for child process. Why? It's always parent and child relationship, tree structure. So while you are playing outside, your mom and dad are waiting until you return. They will not do anything. Just waiting. Same the process. When I type the command, like the ls, during the ls, the parent, my current shell, will not do anything. Just wait until the end of the program. That's the reason. Sometimes when you pop up the notepad from the command line, you cannot use command line. You cannot use the command line. Okay? Why? Because parent process is waiting to the termination of the child process. It's not fair, so we will see how can we avoid such a thing. This is called the background process. So this, the two system library is the most important library in operating system, fork and exec. There are variations, V, sometimes exec, LP, but they are the variation of this. Okay, then this is the process, Windows API. Windows is the same mechanism, but they combine these two. This always work pair. So create. Win32 API use create the process. But it's combined into one system library. Then you are able to create the process using this. Next class, I will show you the example code, how to use this one, fork and exec. Okay. Let me change. Within 10 minutes, we are going to complete the exercise lab today. So please pop up your incognito, the windows. Then I sent the link for the coupon code. So for example, like this one. Where is it? Yes, here. So you can see this. So why don't you find your inbox on Canvas, and I sent this link with the coupon code. Copy and paste. So copy and paste to here, and my code. Where is my code?
Professor, can we raise this, please?
Oh yeah, okay. Please do not use your UB account to log in Gmail and to log in the Google service. Do not use your UB account, UB email, because UB account is based on the Gmail, Google account. However, IT service block all the UB account to use the GCP. Okay, there is no option.
Use the regular Gmail.
Regular Gmail, your individual Gmail. So if you click, enter this one, you will be asked to sign. At this time, do not use my.bridgecode.edu. Instead, you can use your individual. I'm going to use this. Then log in. Very important, once you activate, you cannot revoke. So please use your individual Gmail. Then if you can see this CPSC308 and August 30, 2021, $50, it's okay. And then accept and continue. Accept and continue. Because this is your first time the use, if you already activate, so you may have another one. So let me explain how. So Google has the organization. GCP has the organization, like a company. Under the company, there are a number of billing accounts. Think about your house. Your mom and dad, your family is the organization, one organization. Under your family roof, you may have the multiple credit card. Billing account, multiple credit card, multiple credit card. Okay? Right now, if you activate the coupon, that is one billing account, no organization. It's okay, no problem. We are not going to set up the organization. Instead, your billing account will be created based on your coupon code. Otherwise, you need to put your credit card information. You will be charged. So do not put the credit card information to create the billing account. It will be disaster. Not disaster, $30, $40 will be paid every month. Like that. So once you activate the billing account based on the coupon will be created. So you have one billing account. Then finally you can create the project under the billing account. Without billing account, you cannot create the project. Project should have at least one billing account. So once you activate, so here you have, in my case, I activate the two coupon code. One is for NoSQL, another one is for the operating system. But in your case, you have this one, right? Then next thing is that you need to create the project. You can click Google Cloud Platform. Okay. You can click select the project and one new project. Or in your case, you may be asked directly to create the project. What happens after you activate the coupon? Did you? You have multiple coupons, so you can select.
You open your email first, that's right.
Okay.
No,
Then here,
he sent a link.
Yes.
I opened the link.
so you can create a new project.
To my Gmail.
So then you can give the project name. You can give the project name OS, and please use your the UBID. In my case, 1111, but you can use your UBID, then I can easily recognize who is whom. Then you can select the billing account if you have multiple. If you are taking both the NoSQL and operating system, you are able to select. I'm going to select the operating system. Then the location, no organization. In this case, we didn't create the organization, so create. So we create the 1111, the project. So if you go back, so you can select your created project. Always, you need to select the one project to use the service on GCP. So first thing, you need to activate the coupon. Second, create the project. If you have the first coupon code, it's straightforward because no existing billing account, no project. You can just create. If you have multiple, you can always select and create like that. So right now, I selected. So from now on, once you select create the project, you don't have to select the billing account until you dry up all the coupon code. Okay, so far so good. Then next thing is we are going to create the compute engine, our computer. So this is called the compute engine. There are two options to select the service. One is search. Another one is, this one is called the hamburger menu. It's like a hamburger. Hamburger menu, if you click, there are a bunch of the service. So you cannot find, it's not easy to find the whole the services. So it's recommended to use the menu, top menu. So compute engine. If you type the compute engine, there is a service on top. You can click compute engine. Since this is the first time to use the GCP service under the OS 1111 project in your project, you may direct it to the create the VM instance. First time, it's a little bit time, takes a time. You can see always the top icon is running. So initializing compute engine for project OS 1111. So you can, they are enabled the service, the API. So whether you are able to use or not, and so on. Change the service to this. I already enabled this before. Okay, So if you can see this menu, you are ready to create the compute engine, computer on cloud. So just click create. Then you can give your computer name instance. Okay. Then you don't have to change the region and zone. So they usually use the default. And here you can configure your computer. So for example, you don't have to use a very expensive one. Just use a minimum specification. So for example, the E2 is I think the CPU based. So it's okay. And machine type, even we don't need multiple CPU. I'm going to use a micro. Micro is 1 GB memory. It's the cheapest one. And then, so you can select your operating system on the boot disk. So change. You can see the operating system type, CentOS, the Debian, even deep learning on Linux, and the Red Hat SQL Server. You go into Windows Server. We are going to select the Debian operating system. If you select a different one, sometimes their interface is slightly different. Okay, so if you are not familiar with the Linux, please select the Debian. So because the GA will use the Debian operating system. For the disk type, definitely SSD is expensive than the hard disk drive. So I'm going to select the standard persistent disk. So then select. Okay. Then allow default access. Please allow the HTTP traffic also. Then click create. That's it. It's very simple. It takes 1 minute to create your server. Okay. Just wait until this mark left hand side is stop green. Yes, done. So today's project, the exercise is done. But I'd like to show one more thing. So how can I access my computer? So this is your homework. So first, click the SSH here. There are different ways to access the virtual machine. This is the easiest way. You can click right hand side SSH button. So this is your computer. The compute engine. You can do the ls, you can do the top that I showed you before, okay? And you can do anything. So here, what you're gonna do is, I don't want to use this is like this one. This is your computer, the Chrome. You are using GCP console. Then connect to the cloud, GCP cloud. You create the compute engine. Compute engine. When you click the SSH, that is not from the laptop. Instead, here inside your cloud, so you are going to SSH. Okay? All these are based on GCP console. This is one way. But the only downside is you should use browser. Always should use the browser. So if you don't want to use your browser, I want my own client. For example, VNC client. To do that, VNC is the remote desktop program. When you access a computer remotely, you can use the VNC client, which means VNC server should be running. So homework. If you go back to this one. Alright, so exercise lab document. So we create the virtual machine. If you cannot follow right now, why don't you go read the exercise lab description, then follow the step. Then we are in this step. We create. Then if you want to access from your laptop using GUI, graphical user interface, why don't you follow the step. 1.3, connecting your instance computer using the VNC graphical user interface. To do that, first you need to install the VNC server on your compute engine. Follow the command. Then set up. You may not have NC. It's okay. If you just type the VNC server, it will work. Then on your laptop, you are going to install the VNC viewer client. Then also you need to open the firewall for VNC connection. So it's a server side, the GCP console. You can set up the firewall, the rule. Then finally you are able to connect from your VNC viewer. Okay. So this is your homework. So why don't you create the compute engine and connect your server from your client module. Okay. Questions?
Where is that guy?
Which guy? This one?
Yeah.
You mean the document or the document?
The document.
Document always on Canvas.
Okay.
Why don't you read it, then follow. Okay, thanks so much. Let me check the question from the chatting box.
Yeah, that's this one.
Okay, so question.
This is the
Yes.
you want to-
Yes, Christopher. That's the reason the global variable is not the recommended. It looks like the easy, but it will not free up until the end of the program. Also, maybe vulnerable to be attacked. Yes, right, Irvin. The
This one.
heap area hold the pointer,
This is the
address of the array, temporary data.
No, not this class. I use this for a different class.
That memory, the Christopher, the heap has the only pointer. Then any available space out of process structure will be
That's what I
used.
gotta create.
It is already working.
Yeah, outside, it's not out of memory, out of memory structure for that process.
Oh, this is a Windows.
Yes, right. The PCB, instead of managing all the PCB address, it's based on the link. So it's connected. Then as a queue, it is managed.
Who, me?
The Kimani, the link I already sent to your
Yeah.
Canvas message. So why don't you check your Canvas message? If you cannot find it, contact me again. Okay? Thank you. So if no other questions, so please follow the instruction described in the exercise log and activate your coupon and create your compute engine, connect from your laptop. That is your homework by the next week. Thank you and stay safe. We will see you the next week. Thank you. If we can do the lecture like the normal situation, operating system is much more fun. With the practice and the exercise, the operating system class is much more fun.
Is that operating system?
Yeah, but it's very limited right now.
All right, thank you for that.
Yeah, thank you.